Hey fifth graders, Ms. Shames here. Today we're going to dive into Module 7, Lesson 6, continuing our learning about coordinate planes, and especially continuing our learning about thinking about patterns on a coordinate grid. So today our teaching point is that mathematicians will investigate patterns in vertical and horizontal lines and interpret points on the plane as distances from the axes. So we're continuing our teaching point from yesterday and getting deeper into thinking about these patterns that we're seeing on a coordinate plane. So how are you going to know if you're successful? Here's your success criteria. By the end of the lesson, you'll be able to identify if a line on a coordinate plane is parallel or perpendicular to an axis. You will also be able to describe patterns in coordinates of a horizontal or vertical line on a coordinate plane. And you'll be able to identify the distance between a point and one of the axes. Let's talk about some of our vocabulary. So this is the same vocabulary that we were working with yesterday, and we want to continue practicing it, using it in our writing and speech, and we'll also see this vocabulary throughout the lesson. So keep your eyes and ears open. So parallel is one of our vocabulary words, origin, x-axis, coordinate pair, perpendicular, and y-axis. Take a second to reflect on these words and ask yourself, which words have I been using a lot in my writing and speech about math, and which words do I want to start using more? All right, so in today's lesson, you're going to see me model some problems on the coordinate plane, and these are going to be kind of tricky questions that help you think deeply about what's happening on the coordinate plane. Let's get started.
Hey there, Zerner. Today we'll continue our work with the coordinate plane. Working with the coordinate plane is a bit like solving a puzzle. We get clues about a point's location, a coordinate pair, and then get to show the exact point's location. Or vice versa. We see a point and need to solve for its coordinate pair. Here's our first clue. Point A is at 2 1/2, 1 1/4. Plot point A on the coordinate plane.
All right, so we need to plot point A at 2 1/2 and 1 1/4. Remember, the first coordinate is the x-coordinate, and the second coordinate is the y-coordinate. So the first coordinate, the x-coordinate, tells me how far I need to go on the horizontal x-axis. So if I want to go to 2 1/2, let's first think, what's one hole on this number line on these axes split into? So if here's 1, I'm going to look at this hole and think about how many parts it's split into. Well, I can see that it's split into 1, 2, 3, 4 parts. So that means the number line is counting by fourths. So this would be 1/4, 2/4, which makes 1/2, 3/4, and then 4/4, which is 1 whole. So if I want to go to 2 1/2, I'm going to go all the way to the 2 tick mark. Then I'm going to continue up 1 would be 2 1/4. And up another tick mark would be 2 2/4, which is the same as 2 1/2. So we'll go over to here, but now we need to go up on our y-axis to 1 1/4. So let me go up to 1, and then I need to make one more jump on a tick mark to get to 1 1/4. So point A would be here. Yay.
So point A is here. Let's think about this point in terms of its distance from each axis. The x-coordinate 2 1/2 tells us the distance from the y-axis, and the y-coordinate 1 1/4 tells us the distance from the x-axis. What is the shortest distance to point A from the x-axis?
Let's think about that. What is the shortest distance to point A from the x-axis? Well, if I'm here on the x-axis and I want to get to point A, the shortest distance is going to be to go straight up, not like around. That'll make it longer, right? So let's see how long this distance is. Well, we know that we went up to 1, and then we made one more jump of 1/4. So the distance from A to the x-axis is 1 1/4. And that's the shortest distance. So let's say that the shortest distance is 1 1/4. Yay.
That's right. 1 1/4 is our y-coordinate. The y-coordinate tells us how far a point is from the x-axis. What if we travel from the y-axis? What is the shortest distance to point A from the y-axis?
All right, well, let's think about this. The shortest distance from point A to the y-axis is going to be how far we traveled on the x-axis. So we went all the way to 2, and then we made a jump of 1/2 or 2/4. So you can think of the x-coordinate as indicating a point's distance from the y-axis. So the shortest distance from the y-axis is 2 1/2. 2 1/2. Nice.
I went straight over from the y-axis. Point A is 2 1/2 units from the y-axis.
You got it. 2 1/2 is the x-coordinate of this point. So the x-coordinate tells us the distance from the y-axis, and the y-coordinate of a point tells us the distance from the x-axis. Let's follow some more clues on the coordinate plane. We'll keep going in our notes.
All right, guys, so go ahead and take out your guided notes. They might be on the first page of your Desmos, or they would be printed for you if you're in the classroom.
Here are points A, B, and C, and here is line M. A is the location of our first point. We know it has an x-coordinate of 2 1/2 and a y-coordinate of 1 1/4. Is at 2 1/2, 1 1/4. What are the coordinates for point B and point C? Write them here in our chart. Write the x-coordinate, then the y-coordinate, then the coordinate pair.
So go ahead and pause the video. You can work with a partner in a breakout room or in the classroom and write the coordinates for points B and points C.
Let's start with point B. The x-coordinate is 2 1/2, and the y-coordinate is 2 3/4. So we can write the coordinate pair like this. For point C, the x-coordinate is also 2 1/2, and the y-coordinate is 2. So this is the coordinate pair. Check your work.
Okay, go ahead and check your work. How'd you do? If you made any errors, use this opportunity to reflect on them. What mistake might you have made, and how could you avoid this in the future?
Points A, B, and C all fall on line M. All of these coordinates have an x-coordinate of 2 1/2, so any point that falls on line M is 2 1/2 units from the y-axis. Let's draw another line with a few clues. We need a line that is perpendicular to line M and 1/2 unit away from the x-axis. Remember, perpendicular means that the line will form a right angle with line M. Label this new line N.
So let's think about this. So we want to draw a line that's perpendicular to line M and a 1/2 unit away from the x-axis. So remember, that 1/2 unit away from the x-axis means that that would be its y-coordinate, because that's the distance from the x-axis. So here's a half a unit away from the x-axis, and then we want a line perpendicular to line M. That means it intersects it at a right angle. So I'm going to draw the line like that. Oh, this is line N. So just to recap, I knew to draw it here because this was 1/2 a unit away from the x-axis, and it was perpendicular to line M.
Line M and line N intersect here. Plot point D where line M and line N intersect.
Okay, go ahead and put point D where line M and line N intersect. So pause the video if you need to and plot this point.
What are the coordinates of point D? Record them here.
Go ahead and pause the video. You can turn and talk to a partner. What are the coordinates of point D? Fill them out on your guided notes. Write the x coordinate, the y coordinate, and its coordinate pair.
The x coordinate for point D is 2 1/2, and the y coordinate is 1/2. So point D's coordinates are 2 1/2, comma, 1/2. Check your work.
Okay, go ahead and check your work. And remember, if you made any errors, you can learn from them.
How far is point D from the x-axis and from the y-axis? Remember that we can use a point's coordinates to help. Record your answers on Zern.
Okay, so let's think about how far point D is from the y-axis. So I'll do this question, then you'll help me with the next one. So remember, its distance from the y-axis is also its x-coordinate, because that's how far we're traveling away from the y-axis on the x-axis. So we can see that we went all the way to 2, and then we made a jump of 1/2. So its distance from the y-axis is 2 1/2. Two and 1/2. So how far is point D from the x-axis? Go ahead and turn and talk to a neighbor or type into the Zoom chat. So its distance from the x-axis is 1/2, because that's how far we traveled away from the x-axis, as indicated by its y-coordinate. Yay!
Point D is 2 1/2 units from the y-axis. That's the same as point D's x-coordinate. Point D is 1/2 unit from the x-axis. That's the same as its y-coordinate. Here's another clue. Point E is 3/4 unit from the y-axis, along line N. Plot point E on line N so that it is 3/4 unit from the y-axis. Then record the coordinates of E in the chart.
Okay, so I know that point E has to be 3/4 of a unit from the y-axis on line N. So I'm going to start right here, because I know that it has to be on line N. And then let's go 3/4 unit from the y-axis. So let's go 1/4, 2/4, 3/4. So point E would be right here. Go ahead and jot the coordinates of that point. You can pause the video if you need to.
I'll plot point E on line N, 3/4 unit from the y-axis. The coordinates for point E are 3/4, comma, 1/2. This puzzle is a little trickier to solve. Plot point F on line N so that it is 3/4 unit farther from the y-axis than point E. Then record the coordinates of point F in the chart.
All right, you guys, you're going to work with a partner to do this, but make sure you're reading that question carefully. So here's point E. Make sure point F is 3/4 unit farther from the y-axis than point E. So you're going to need to keep traveling in that direction another 3/4 unit. Plot point F and write its coordinates. Pause the video if you need to and work with a partner.
To plot point F, I'll start at point E and move 1/4, 2/4, 3/4 further from the y-axis. Point F's coordinates are 1 1/2, 1/2. Check your work.
All right, go ahead and check your work. Did you make any errors, and what can we learn from those errors?
Here's your next challenge. Using a straight edge, draw a line P that is parallel to line M and contains point F. Remember that parallel lines would never intersect, even if they continued in both directions. Go for it.
So if I want to draw a line that is parallel to line M and it contains point F, so that means it's going to have to go through this point, but it's going to have to be parallel to line M. So let's draw it like this. I'm trying to draw as straight as I can. What do you guys think? Does this meet the criteria? Is it parallel to line M and contains point F? What do you think?
I'll draw line P through point F like this. Line P is parallel to line M. This line is 1 1/2 units away from the y-axis, which means the x-coordinate for every point on line P is 1 1/2.
We want to shade the area with points more than 1 1/2 units from the y-axis. Which area of the coordinate plane should we shade? So let's call this A, B, and C. And remember, we're shading the area that has points more than 1 1/2 units away from the y-axis. So let's think about it, but then ultimately you'll decide. So let's find 1 1/2, 1 1/2. So line P goes exactly through 1 1/2 distance away from the y-axis. So we want to shade everything greater than that. So which one shows that? A, B, or C? Pause the video if you need to. You can turn and talk to a partner or type it into the Zoom chat. So the correct answer was B, because you can see that line P shows exactly 1 1/2 units away from the y-axis. So everything shaded on the other side of that, on the side that's greater, is going to represent this problem. Yay. We also want to shade the area with points less than 2 1/2 units from the y-axis. Which area of the coordinate plane should we shade? So remember, you're looking for the coordinate plane that shows the points less than 2 1/2 units away from the y-axis. Turn and talk to a partner or type into the Zoom chat which coordinate plane represents that. So the correct answer is coordinate plane A, because as you can see, line M is exactly 2 1/2 units away from the y-axis. So here it shows everything less shaded. This coordinate plane B shows everything greater than 2 1/2. So that's why that's incorrect. And coordinate plane C shows everything less than 1 1/2, not 2 1/2. So that's why coordinate plane A correctly answers this question. Yay.
Nice work on the coordinate plane, Zerner. Try this next one on your own. Start by plotting point H at 1 1/4, 1 3/4 on the coordinate plane.
Okay, so I want to plot point H at 1 1/4, 1 3/4. So I'm going to go to 1, go 1 more fourth. That's my x coordinate. And then for y, I'm going to go up to 1 and then to 3/4. So it would go right here.
Here is point H. Which of these lines passes through point H and is parallel to the y-axis?
So here's point H. Here's the y-axis. So a lot of lines go through it, but not all of them are parallel. So line R here, that goes through H, but it's not parallel. Line P doesn't even go through point H. Line S goes through point H, but it's perpendicular to the y-axis. So line N is the only line that goes through point H and is parallel to the y-axis.
Let's keep going. Line T has a y-coordinate of 3/4, so it's 3/4 unit from the x-axis. Let's shade everything below line T. If we plot a point in the shaded area, what do we know is true about that point?
If we plot a point in this shaded area, what must be true about that point? So I'm going to call this A, B, C, and D. So let's read each one, and then you'll decide. The point is less than 3/4 unit from the x-axis. The y-coordinate is 3/4. Remember, we're thinking about all the points in this shaded region. What must be true of them? The point is less than 3/4 unit from the y-axis. The x-coordinate is 3/4. Turn and talk to a partner or type into the Zoom chat, which of these must be true? Pause the video if you need. So statement A is actually true because all of these points are going to be less than 3/4 units from the x-axis, because line T is exactly 3/4 unit from the x-axis. So everything below that, everything less than that, is going to be less than 3/4 unit away from the x-axis. All right, you guys, go ahead and head over to Desmos or open up your packets to lesson 6 for today's independent practice. See you soon.